I make this video for my class HW6-1, and here's the first question in my homework 6. We have already got the density function of xy here and the range of it, so we need to find out the a first. According to the density function, we could know that this equals 1, so obviously we could get a. The a equals 1 by 4. So secondly, we should calculate whether xy are uncorrelated. First, we need to get the expectation of x. The expectation of x dx dy. Here, obviously, it should be ax multiply 1 plus xy. So here, we have already get this result in the first question, a equals 1 by 4. So here, it's really easy to calculate, and here's 0. Use the same way to calculate the expectation of y. The expectation of y is a similar way to calculate. It should be a y. Here is not x, here should be y, because here's the expectation of y. And 1 plus xy dx dy. So 0 as well. Finally, we need to calculate the expectation of x and y. So from this part, ax y, yes, 1 plus x multiply y dx dy. And here, a equals 1 by 4. So obviously, we could get the result. It is 4, 9, a. Here, a equals 1 by 4. So it is this one. So obviously, we know that the expectation of xy does not equal to the expectation of x multiply the expectation of y. So obviously, it's not uncorrelated. Here's the second question, so we're gonna solve the third one. Are they independent? Are they independent? So we need to know the density function of xy. We have already got it here. Here's the density function of x and y. So here we need to use it to calculate the density function of x. Here's the density function of x. Well, 1 plus xy dy is 1 by 2. And x is in the range from -1 to 1. It's a similar way to calculate y. And the range of y is from -1 to 1. Obviously, the density function of xy does not equal to the density function of x multiplied the density function of y, so they are not independent. First, we need to find the joint density function of x squared y squared. So here we're gonna solve the problem. First, we said that z equals x squared, w equals y squared. So according to the range of xy, here is the range. I'm gonna draw that again. -1, 1. -1, 1. So here is the range of it. It could be divided into 4 parts. Here is the first one, the second one, the third one, and the first one. The fourth one. So in the first area, we can know that x equals y equals. In the third area, x equals negative, y equals. Third area, x equals negative, y equals negative. And the fourth area, is negative. So obviously this is a relationship in 4 areas. So here we could solve the problem. But actually it has already been divided into 4 parts, so we're going to calculate it one by one and end them together. So the in the first area, it should be so in the second area it should be in the third area. In the fourth area. So and then together we could obviously get the result. It is 1 by 4 times here. So this result. And the fifth question, we need to find that whether x squared and y squared are independent. Here, in the first question, we have already said that x equals x squared and y and w equals y squared. So here I'm gonna use z and w in the fifth question. According to the first part, we have already got the result that here negative. So we want to know whether it's independent, so we need to calculate the density function of them. And the density function of W the same way. So it equals, we could find that the density function of the W equals the density function of the multiply the density function of W, so they are independent.